Confgure free stop redundancy protocols. What these protocols do is provide you with a redundancy for your default gateway. So you can have many devices that are willing to become the default gateway. Only one becomes the default gateway by means of using parameter known as priority. If this priority dies, the tiebreaker is the IP address. Higher priorities are preferred, and higher IP address are preferred. You must know that this priority can change dynamically while your network operates if you use object tracking. So object tracking will let your protocols know if something important happened in your network as your network operates. For instance, if the connected one link to your default gateway goes down, you might want to move your gateway operation to another device that has a working one link. Another example, if the default gateway of your default gateway stops being reachable, you might want also to move your default gateway operation to a different device that has an operating default gateway. We are talking here about the default gateway of your default gateway. Another example, for instance, if your one links becomes too slow, it offers you high delays, you might want to move your default gateway operation to a different device that has more efficient one link. Let's talk about preemption. As we just said, the priority can change dynamically. The way that object tracking works is like reducing your priority anytime something happens. So if the priority that belongs to the default gateway gets so low that another device happens to have a higher priority, this other device will want to take over the role of becoming the packet forwarder. This will happen only if preemption is enabled. If preemption is disabled, the primary device will not give up its role if its priority gets lower than another device's. So if preemption is disabled, the only way that a secondary device has to become the primary happens if the primary device gets shut down or gets reset or gets disconnected from the broadcast domain. Remember that these devices must communicate through the same broadcast domain. You must be aware that your one configuration must follow your first hop redundancy protocol behavior, otherwise you may end up having asymmetric traffic. This means that asymmetric traffic happens when, for instance, your end users are reaching the internet through one device and the traffic coming from the internet is being forwarded down by another device. So you might want to keep your configurations, your one configurations in check. With the original protocols, the primary device is forwarding and the others are sitting idle. So you can reach some sort of load balancing in order to use your other devices. If you use different configurations in your groups, you can use one or more groups in every VLAN. There is another protocol that was designed with load balancing in mind, which is the GLBP. This will provide you with load balancing across up to 4 devices using one of 3 different methods. And remember that use devices uses halos, different type of messages to communicate with each other. They will use a multicast address across the same broadcast domain, and they will have halo and dead timers. So let's see the difference between them. Hsrp and GLBP are proprietary, whereas VRRP is a standard. Hsrp and VRRP can achieve some level of load balancing using groups, whereas GLBP can provide you with better load balancing across up to 4 devices using one of 3 different methods. The naming convention for Hsrp is that the device that is the default gateway is known as active, the second in line is standby, and the others are speakers. For VRRP, your default gateway is known as master, whereas the other are known as backups. For GLBP, you have one active virtual gateway, or FVG, and up to 4 active virtual forwarders, or AVFs. One device can play the role of being the one AVG and one of the 4 AVFs. These protocols basically use a virtual IP and a virtual MAC address that will be hopping between devices as they become the default gateway. They will use one virtual IP, but VRRP lets you use this virtual IP being used physically in the configuration of one device. Support for secondary IPs, they all support secondary IPs, but some version of some old version of Hsrp will not support secondary IPs. You will have to use groups, and that is the way that each protocol defines virtual MAC address with those formats. Those are the priority range. Those are the 4 priorities. Remember that GLBP also has AVFs that have something that is pretty much like a priority that is known as waiting. You have a lower threshold waiting and an upper threshold waiting as well. Object tracking is, you can use object tracking almost everywhere except for AVGs. Preemption is not enabled by default for Hsrp. It is enabled by default for VRRP. It is not enabled for AVGs, but it is enabled for AVFs. Those are the multicast addresses that are used for each protocol. The version 1 for Hsrp may conflict with other protocols. However, the UDP number must be different in order to avoid the conflict. The tiebreaker for the priority is always the IP address. Those are the hello and dead timers for each protocol. Notice that VRRP has a formula to calculate the whole timer, and the GLBP has other timers like the redirect timer and failed forward timer that happens when an AVF fails. Those are the groups. The authentication, you can use plain text or MD5. The states, Hsrp and GLBP states are almost the same because both protocols come from CISCO. VRRP states are initialized, backup, and master, and your packets are different for each protocol. Remember that VRRP does not have hellos, but VRRP advertisements. Support for IPv6, version 2 for Hsrp, version 3 for VRRP, and GLBP supports IPv6. They all support VRFs. GLBP is a bit more complex to operate. And basically, each time an end device asks for the MAC address that belongs to the default gateway, AVG may reply with different MACs each time. This virtual MAC address belongs to the active vector forwarders. That means that each AVF has a different virtual MAC address to work with, and the AVG chooses how these virtual MAC addresses are handled to the end devices. Depending on the load balancing algorithm, you have 3: host dependent, round robin, and weighted. What happens if an AVF fails? Usually an idle device will take over, but if you don't have an idle device that takes over the role of the failed AVF, an active AVF will have to take over the role of the failed AVF. That means that in that case, this active AVF will be handling 2 virtual MAC addresses. The virtual MAC address that was handled by the failed AVF will eventually stop being used after the redirect timer and failed forward timers run. Remember that you have AVF states that are disabled, initial, listen, and active that are different than the AVG states. In order to configure Hsrp, use the standby command, and in order to troubleshoot, use the show standby with all the different parameters. VRRP is configured with the VRRP command. There is a new way to configure it if you used the version 3. You can use address families. In order to troubleshoot VRRP, use show VRRP with a lot of different parameters. In order to configure GLBP, use the command GLBP and the group number. In order to troubleshoot GLBP, use the show GLBP command with different options. We are going to see all these options in the labs.